Hi everyone, I'm Yukun Zheng, a third-year master's student from Tsinghua University. I'm so glad to be here and give the presentation of our recent paper named Investigating Examination Behavior in Mobile Search. Five authors of us are from Tsinghua University and one is from RMIT University. Here is the outline of my presentation with four parts. The first one is our motivation. Compared to desktop search, today's mobile search has a number of differences. The first one is the small screen size of mobile devices. The user can view fewer results on the screen of a mobile device than on a desktop computer. Next, results in mobile search become more heterogeneous with various presentation styles. Existing works show that the behavior patterns of users in mobile search are quite different from those in desktop search, such as stronger precision bias and more good abandonment. In addition, the screen sizes of mobile devices become larger and larger in recent years. Now, most of the popular mobile phones have a 6-inch screen. However, the recent work on eye tracking in mobile search is lagging in 2014, which is conducted on a 4.7-inch mobile phone. They found that most of the user's attention locates on the top half of the screen. However, we don't know whether this finding still works with larger screen sizes of mobile devices. Users' attention can reflect the attention allocation mechanism of users. Here we list several factors that may affect users' attention. The first five factors have been studied by previous works. Besides these factors, we assume that users' attention may also be affected by some other factors in mobile search, such as the browsing depth, the position within a viewport, the click necessity of results. We investigate these factors in this paper. In our mind, accurately modeling users' attention during a search process can help improve a number of IR-related tasks, such as these tasks we list here. Based on these motivations, we propose our three research questions. The first one is to investigate how users examine SERPs on mobile devices with a large screen size. The second one is to analyze the factors which may affect users' attention. The third one is to incorporate our findings into a practical search application to show their effectiveness. We conduct a user study to collect users' examination behavior during mobile search. Here, I will briefly describe our user study. There are totally 60 mobile search tasks. We scrolled SERPs from Sogo.com, which is a popular search engine in China. We recruit 13 students from Tsinghua University as the participants. It takes 1 hour to finish one search group with 20 tasks. Here is the procedure of our user study. We first guide users to accomplish two training tasks. Then users are asked to finish 20 or 40 tasks by themselves. In the task, they first read the query and the corresponding background of search intent, which is made up by ourselves. Next, users need to browse the given SERP on a mobile phone. They can hold the phone, but they cannot move or rotate it. We also collect some feedbacks from users about the search process, such as the search success and satisfaction. Here are the settings of our user study. We use a OnePlus 5T with a 6-inch screen as the experimental mobile phone. We develop an experimental system with an Android app and a Django server. We use an eye tracker with a mobile device stand to collect the user's eye tracking data on mobile device. Here we show a video of the user study. During the browsing process, users' eye movements will be collected by our eye tracker. As we see, The moving red dot on the screen is the focus of the user. We collect some annotations for results in our user study by crowdsourcing, such as page relevance, snippet relevance, click necessity, and result type. After the user study, we make an analysis of the collected behavior data. We examine the first arrival time at different vertical positions of SERPs. We find that the user generally browses the SERP from the top to the bottom. Then we examine the viewport-based examination behavior of users. We can see that when the user browses deeper on the SERP, the less attention they will pay to results. We looked into the user's attention within the viewport. We also name it viewport attention in our paper. From the left figure, we can see that when the viewport offset is 0, the users pay more attention to the top half of the viewport. When the users start scrolling, most of the attention locates on the bottom half of the viewport. From the right figure of two eye-tracking heat maps, we can also see the same pattern. Further, we analyze the factors which may affect viewport attention. We find that the first two results usually attract more attention from users than other results on the SERP. When the result covers more area and explores more of itself in the viewport, it attracts more attention. Here we show 6 popular result types in our dataset. Some features of vertical types, such as more images, more words, larger height, and allowing users to interact with snippets, help attract more attention from users. Here we examine the relationship between users' attention and the results click necessity, as well as the snippet relevance. We find that highly relevant results with low click necessity usually attract the most user attention than other kinds of results. In the final part of the paper, we choose the click prediction task to test the effectiveness of our finding. Previous works show that click models are effective methods to collect implicit relevance feedback from query logs. We use search logs from Sogo.com as a dataset. We reserve the sessions whose resolution is similar to that of the mobile phone in our user study. We also remove search sessions with no clicks. This is a click model recently proposed by us named viewport time click model. It follows mobile click model and takes click necessity bias and examination satisfaction bias into account. Different from existing click models, WSDM considers viewport time of each result as the second observable variable besides clicks. WSDM models the relationship between the viewport time, result type, examination behavior, examination satisfaction, and user clicks. In this paper, we first try to incorporate the patterns of viewport attention into the calculation of viewport time. In the original WTCM, the attention is considered to be equal within the viewport. Here, we take the viewport offset into consideration, as shown in the right equation. There are two conditions: when the viewport offset is 0 and when it is larger than 0. As for W function, we follow WTCM and use the explorer ratio of the result in the viewport as the weight. In this work, we use the statistics of user attention under the two conditions in the user study as a V function. With the new viewport time, we can see that the performance of VTCM got significantly improved in click prediction. We examine the click position in the logs and find the same pattern as user attention. This provides evidence to support the effectiveness of our improvement. Then we incorporate the result rank into the modeling of viewport time probability as shown in the equations. We divide the result ranks into two groups, the first two and the later eight, according to our findings. Our results show that this also brings improvement to the performance of VTCM. Finally, we incorporate the two improvements into VTCM together and got the best performance among all methods we used in this experiment with statistical significance. In conclusion, in this paper, we investigate how users allocate attention in mobile search on a large screen, especially within viewports. We show the attention may be affected by several factors, such as result rank, viewport offset, result type, and presentation styles, snippet relevance, click necessity, and so on. Finally, we show our findings can be successfully applied in the click prediction task. In the future, we want to incorporate more findings in this paper into click prediction and other related tasks. We only conduct the experiment on a certain mobile screen size. In the future, we want to investigate the generality of our findings on other mobile screen sizes. In addition, we may also better infer users' attention during mobile search using machine learning methods based on our findings. That's all. Thank you for listening. Any question?